Hey everybody, I want to jump in and work our way through subtracting mixed numbers. I want to show you two different ways to go through it, and then you can kind of decide which way you would like best. What I'm hoping to point out is maybe some pitfalls of one method over the other. There's a second video or an alternate video where I go through with some different numbers, and maybe you can see the benefits of the two different methods. Okay, let's jump right in. So what you see up in the top left, there is our subtraction of mixed numbers. If we were to go through and try to do this operation while maintaining our mixed number form, then what we have to do is we have to take a look at that and almost deal with it as two operations. Like we're going to deal with the subtraction, but in two parts. That is, I need to go through and subtract my whole numbers, and then I need to add to that the difference in my fractions. And so what you'll notice is I'm calculating, not that these brackets are really needed, but I'm going to go through and I'm going to calculate that. So when I work my way through, I'm going to deal with my gold. Well, my bracket's now needed. I'm going to deal with my gold. So I would calculate my 1 minus my 2 and realize that that is my -1. And then what I need to do is I need to add to that the change, the extra difference in my fractions. So I could go through and get my common denominator of 12. That means I have to double my 1. That means I have to triple my 3. When I go through and I calculate that, I'm now going to have my add. I notice that my difference of my fractions is a -7/12. So when I combine, when I collect the outcome of that, I have a -1 from my whole numbers minus 7/12 more with my fractions. And so if I turn that into like a fraction operation, I notice I'm going to subtract 1, have a -1, and I need to subtract more. So if I change my 1 into twelfths, then that's a 12/12. I have a -19/12 as my final value. That could be a new way to tackle some things for some people. And the fact that when you went through and you dealt with that fraction operation, let me just shrink that down a little bit, and you had a negative fraction when you collected your parts, and you add a negative whole number, that could add a little bit of a wrinkle. I'm hoping that we clarify some stuff, but that can add a little bit of a snag or common mistake. If you were looking for a universal way to tackle that problem, then my suggestion to you would be to do the green. That is, just start off and say, well, if it's the mixture of the whole numbers and the fractions that causes a snag, then just change everything to an improper fraction. That is, I change 6 or 1 1/6 into an improper fraction, and that is my 7/6. I now subtract, I change my 2 3/4 into fourths, so that's going to be an 11/4. I'm just following that algorithm, right? 4 times 2, that gives me 8/4, 8, and then I need to add on my 3. There's my 11. Now I can get my common denominator, still the same, my 12ths. I'm still finding the same size pieces, the same size bits. Okay, I have to work with some bigger numbers because I've chosen to create those improper fractions, but I'm doubling 6, so I double 7. I am tripling 4, so I need to triple 11. And now when I subtract my 14 minus, or when I simplify my 14 minus 33, there is my -19/12. And there we go. Okay, the most universal way to tackle that problem would be the green. Regardless of the size of the numbers I'm working with, that gives me a pretty common approach. Change your mixed numbers into improper fractions, simplify. But if you like working with mixed numbers, there's a method in the gold that you can follow. Just be very conscious of all your negatives if they happen to pop up. Okay, I hope that helps you. Best of luck with your practice.